Okay, here's problem number 2. Yes, here's problem number 2 on the test that I don't think we worked this exact problem, but we worked a lot of problems, and I told you, anybody who wants to enlighten us on what I told you about to look for in this problem, what to not do? Anybody remember? A large number of you did this. Brought the 3, made it 1 over 3y dy equals 1 over 2 plus x dx. Okay? That's what I told you not to do. All right? Because it's okay if you did that, if you do it right the rest of the way. Here's the problem. If you do it this way, now you've got to think u equals 3y, so du equals 3 dy, 1/3 du equals dy. So now when I integrate this, I'm integrating 1 over 3 times the integral of 1 over u du. That becomes 1/3 the ln of 3y. Okay? Most of you just wrote down ln of 3y. It's 1/3 the ln of 3y. If you do that, then you'll get it right by doing it that way. But most of us did not do that. The other thing that some of us missed is we chose to not put this c in, as an ln here and combine those two things correctly. But if you did it this way, if you brought the 3y over, this is what you were supposed to do. Now we can say the ln of 3y to the 1/3 equals the ln of c times 2 plus x, because I can put those two things together. That was a mistake that a couple of you were consistent. You made this mistake all the way through the test. Okay, so it's good you were consistent, but it's bad that you made the mistake. So be sure you put it as ln and then combine those two together. You can't just put the plus c on at the very end like that and get it correct most of the time. Well, what do we do now? The ln's go away. So we've got 3y to the 1/3 equals c times 2 plus x. We were told to solve for y, so we need to raise both sides to the third power. 3y equals c cubed 2 plus x cubed. Okay. Now remember that c cubed is okay to just change it back to a c in a minute. And if we're going to divide by 3 cubed over 3, 2 plus x cubed. And this number right here we could write as just a plain old c at the end there. So that was the answer that I was looking for there. And some of you got there beautifully and some of you did not. So that was a careless mistake there. If you left the 3 over on the right side to begin with, it made life lots easier. Because suddenly it was just there and poof, you got there in about 2 steps. So that was a problem that I saw. Number 5 that everybody moaned and groaned about, for the most part you did okay on that, I think. I'm trying to... There was no common mistake on number 5, I don't think. Most of it was a sign mistake somewhere that you just got lost in everything that you were doing there. So if you got, if you got 7 or 8 points on that one, you did a humdinging job there. It was. Any other questions as you look through the test?
I'm guessing if you have a blue circle out the side of one of the things, that should probably have a negative sign.
That's right. There should have been a negative sign there. It got lost somewhere in transmission there.
Maybe that limit thing?
The limit thing, yeah. Okay, so we've worked through, this is 9, and we've worked through and found out in B part, we found the solution to be y equals negative e to the 1/2, is that right? Minus 1 over x plus 1. Is that right? Yeah, that's what we found it to be. Okay, now C part said take the limit as x approaches infinity of this number plus 1. Okay? Well, when we're looking at this, how do we solve a problem like this? X is going to infinity. Okay, so let's just talk through it. Yeah, we can plug in bigger numbers and our calculator really kind of goes haywire after a while. The hard part about plugging in numbers is you got to be sure you've got that in the right format in your calculator. So I would be careful with that. Here's what I want you to think through. Infinity is a real big number, right? What's 1 over a real big number? It's a really small number. It's becoming 0, right? So if it's becoming 0, what is this up here? 1/2 minus a really small number is getting closer to 1/2. So then you could come up with negative e to the 1/2 plus 1 for your answer, which you could write as 1 minus the square root of 1/2. So it's very difficult to work out, I think, but if you could just think through it, it worked fairly quickly there. But I didn't expect a lot of folks to get that right. So, if you didn't get there, now you've seen it one time. Maybe you'll remember it next time. Okay? Anything else? The domain. Okay. The domain is really just, at the top it says x is not equal to 0. Okay. Now, why is that important? Because most of you got y equals negative 2x minus 1. Why can't all reals be the correct answer there? Because I can put any real number into y equals negative 2x minus 1.
Because the function only exists when x doesn't equal 0.
Right, because the only time this function works is in conjunction with the differential equation up top being accurate. Well, the only way the differential equation can be accurate is if x is not 0. So that it was kind of a trick question to be sure you could go back and realize the fact that it couldn't be 0 up there means it still can't be 0 down here. So, all right, pretty good test overall for most of us there. It is in RenWeb now, so what you see is what you get unless you owe me something right now, okay? That's what you've got going into. Yeah, you've got FRQ. That's it.
Got the last page of it.
All right, that's good. So we can get those done and life will be good. Third quarter will be over. All right? Today we are going to begin discussing area. And you say, we've already discussed area. Well, we're going to be discussing it in a little different manner. I think it's very important for you to pay close attention today because it's going to be easy for you to say, I know what area is, so I don't need to worry about this. It's not that easy. The concepts that we're talking about today, it's important that you understand the concepts because when we start spinning things around the x-axis and spinning things around the y-axis to make volumes in a week or so, if you don't have a good foundation here, it's really going to blow your mind. So it's really important. I'm going to try to relate it to some things that we've done before in geometry to hopefully keep you with a good understanding of what's going on here. So really, I'm going to change from my plans here. Before we talk about area, I want you to look at this geometry problem, okay? Okay? I've got a line segment from A to F, and the point D is between them. Okay? If I tell you that AD has a length of 12 and AF has a length of 20, can you tell me how long DF is? How do you do that? It's the length of AF minus the length of AD. That's pretty straightforward, would you agree? What if I turn this line, and here's A, and here's D, and here's F? Has it changed anything? What if I turn the line the other way and put A at the top? Does it change anything? So it doesn't matter where it is, that it's the same type process. What if I told you that AD was 6 and DF was 7? Could you find AF? You would add them together. You do 6 plus 7 and get 13. So it's not a hard problem in that respect, okay? We're going to take this and expand it in 2 dimensions instead of just 1 dimension, okay? So we're not there yet, but let's look at this. It's important that you start understanding what all of this means, because this can scare you to death here. Find the area of the region bounded by the graphs of the following curves. My suggestion to you is to write it out, to draw a picture of it, or a pretty close picture of it. It doesn't have to be perfect, but pretty close. X cubed, what does x cubed look like? Anybody remember?
No, it's like no, that's a square root.
Mm-hmm.
Is the thing that goes like a little S?
It's a lazy S, yes. It's a lazy S, okay? What does the plus 4 do to it? Up 4, okay? So here's our y-axis, here's our x-axis. We know it's a lazy S. It's up 4, so let's just say that's 4. So we're talking about something that looks like that. That's what this curve is right here, okay? What's y equals 0? What does that look like?
It's y. It's just a line.
It's just a line, but which line? Y equals 0. That's the tricky part. Is that this line or this line? This line. So here's y equals 0 right here. That's y equals 0. All right, where's x equals 0? That's the vertical line. So x equals 0 is right here. And then where is x equals 2 then? Same looking thing, but 2 to the right. So it's right over here. And no, I'm not concerned that you are exact on where they are. I mean, just a general idea. So those are the 4 curves that it gave us there. And we do consider all of them curves, even though 3 of them are straight lines, because it would work the same way if it were curves or if it were straight lines. Now it says, find the area of the region bounded by the graphs. What on earth does that mean?
Maybe that part in the middle one.
Yes. What are we looking to find? We're looking to figure out what the area of this part right here is. There it is. This area right in here. So what is that area? That's what we're trying to find. All right? You got any ideas on how to find that area? What have we talked about instead of area is this? Integration, okay? So logical thing is we're going to be integrating. All right? Now, what do you need to do? What do you need to know for integration there, you think?
Could we integrate from 0 to 2?
All right, and why do you think 0 to 2?
Because that's where you're going on the x-axis.
Think of this as where you're starting and where you're stopping, okay? We're starting right here at this line, and we're stopping at this line. So think of it as if you're walking and you're starting at x equals 0, and we're going to be moving in that direction. So we're going from 0 to 2. Okay, now, we're going from x equals 0 to x equals 2. So what variable are we integrating with respect to? X equals 0 and x equals 2. These are both x numbers, so that means we're integrating with respect to x. Why did I write y then? We're integrating with respect to x. Okay? Why is that important? That means whatever's in here, the only variable it can have in it is x. Okay? Now, here's where I want you to just start thinking of... Anybody got an idea of what to put in here? X cubed plus 4. Right. I'm going to put something a little more generic because I want to start this getting ingrained in your head, okay? It's top minus bottom. Okay? Top minus bottom. So look at the functions. When I say look at the functions, well, what do I mean by functions? What of the equations up there have we not used yet? X equals 0 came right over here. Y equals 2 came right there. So we haven't used the other two functions. So it's the top function minus the bottom function. The top function is? All right, the bottom function is? All right, so we're going to be integrating from 0 to 2 of x cubed plus 4 minus 0 dx. Is there any reason to really write the 0? No. But I'm writing it there just to get ingrained in your head, top minus bottom. Okay? Top minus bottom. Now, integrating that should be a breeze compared to what we've been doing. X to the 4th over 4 plus 4x. Evaluating it at 0 and 2. So if we put 2 in there, we get 16 over 4 plus 16 minus 0 over 4 plus 0. That's not 16 that right there, is it? It's 8. And we get 4 plus 8 is 12. So that tells us the area between those four curves is 12. Okay? Complicated yet? No, it's not complicated. Well, let's keep moving forward then. Y equals x cubed plus 4, that's what we just had. X equals 0 and x equals 2, that's what we just had. That's something different. So let's go draw our picture first. Okay? We've got an x-axis, a y-axis and an x-axis. All right, so let's start drawing our curves. We know that this one looks something like this. I'm going to skip over that one for a second. We know x equals 0 is right here. We know x equals 2 is somewhere over here. Now, what is y equals negative x? What's that?
I have no idea.
Anybody got? Is that? It's not a cubic equation. It's a line. You need to think y equals mx plus b. Well, the b is what in this case? 0. So that means we know it goes through 0. What's the m?
1.
Almost. Negative 1. So what does that mean? It's just a falling line. It has a slope of negative 1. Down 1, over 1. So we've got an equation like this. Okay? Now, remember, this purple line right here is not part of our functions. So what area are we trying to find now? Where are my highlighters at, I wonder? We're looking from the black line over to this red, up to the blue, over to the green. That's the area we're talking about. It's almost like a trapezoid-looking thing or a parallelogram. But remember, this top piece is curved. So we can't say, okay, it's 1/2 base 1 plus base 2 times height divided by 2. All right? But we're going to use the same common sense we were saying before. We're going to integrate. What are our limits of integration? 0 and 2. So we're integrating with respect to x. Top, what's the top function? X cubed plus 4. Minus, what's the bottom function? Minus negative x. You have to be careful with that, okay? Minus negative x. All right, so again, this is a simple integration once we get here. X cubed plus 4 plus x dx, and now integrated. X to the 4th over 4 plus 4x plus x squared over 2, evaluated at 0 and 2. Do we expect this number to be larger or smaller? Larger. Because doesn't that look like it's a bigger figure? All right. I'm going to see if I can throw a monkey wrench in that in a moment for you. So we've got 16 over 4 plus 8 plus 2 minus the zeros are just going to make it 0. So we've got 14 that time. Okay? We all right with that? Now, that is correct. Okay? Is anybody struggling? Is anybody struggling with anything we talked about when a figure was underneath the curve?
Oh, because it'd be negative.
Do y'all remember us talking about that? That if a curve goes under, when we integrate, the area becomes negative, right? Well, let's talk about this here. Would it make any sense for this figure to have less area than that figure? No, because you can look at it and tell it's obviously a big figure. So where did the negativeness go to? Remember, our basic formula is top minus bottom. To find the area just below this curve, we would just integrate negative x. But we're subtracting negative x. When you subtract a negative, it makes it positive. So that's the reason that we're winding up with the correct answer here. Now, you probably won't find top minus bottom in any math book anywhere. Okay? It works, so I'm trying to give it to you so you can work through it there. It's the top function minus the bottom function. I keep saying that because you've got to get that ingrained for the next 3 or 4 weeks. All right, let's keep moving on. Find the area of the region bounded by the graphs of... What's different this time? We've only got 2 functions. Well, we've had 4 the last 2 times, so let's draw this picture and see what we've got here. All right. G of x is x, so what's that going to look like? Yes, sir. All right. Y'all see if y'all can figure out what those look like. So we figured out what it looks like. Y equals x is a line. We agree with that? And it looks something like this.
That's a parabola.
A parabola, okay. What's special about this parabola?
It's upside down and it's 6 up the y.
So here's 6 up, and it's upside down. And that's all we got. It says find the area of the region bounded by the graphs. What area do you think that's talking about? This region right here makes sense, right? Okay. All right. So what's the problem we have then? We don't know where to start and where to stop. 0 to 6. Okay. Let's think about that. 0 would be right here, wouldn't it? And 6 would be right here.
I think it's when the intersections of...
Where they intersect. So from right here to right here. Okay. All right, let's focus on the 0 and 6 first. Let's focus on the 0 to 6. Does this look like it covers all the area? Okay, so I think we can safely say that's not going to be it. If we could go from here to here, that would safely get all of the region in there. But we don't know what they are. But what's special about these points right here and right here? It's where these 2 things intersect. If they intersect, that means they are equal at those places. So what happens if we set 6 minus x squared equal to x? Is that a solvable equation for us?
Yeah.
Tell me what we're going to do then.
Do the minus x squared to the x side, and the 6.
Like this? Okay, we move everything. Why don't we just leave that 6 over there by itself, Colin? It'd be a lot easier to factor.
Because then you can't do the x factor. You'll lose an answer.
And what will Mr. Ely do?
He'll do something.
He'll pitch a fit, okay? Remember, quadratics, you have to be equal to 0 to solve quadratics, okay? So now we can factor this puppy. Tell me what kind of answers we expect to get looking at the graph. 1 positive and 1 negative. So we at least know we should get something like that. Is it safe to say that it's going to be less than 6?
Yes.
Because this is 6 out here, so it's safe to say we're expecting it to be less than 6. So how does this factor? X plus 3, x minus 2. So that gives us x equals negative 3 and x equals 2. Why did I write negative 3 again? I don't know. X equals 2. So, what are we going to do from here then? Well, now we have limits of integration. We're going from negative 3 to 2. Top, which function's on top? 6 minus x squared minus bottom x dx. And then the integration is the easy part, isn't it? Did you ever think you'd say the integration was the easy part? I mean, that's just, Think of it. 3 months ago, you had no idea what the word integration meant. And now you're saying integration's easy. I mean, it's... Okay. So we go ahead and we get 6x minus x cubed over 3 minus x squared over 2, negative 3 and 2. We're not going to have a zero answer this time because we've got 2 and negative 3 in there. So be careful that you put everything in right. 6 times 2 minus 8 over 3 minus 4 over 2. I'm going to put everything in parentheses just so I don't get myself lost. Minus negative 18 minus negative 27 over 3 minus 9 over 2. Okay? Look carefully at my signs out here. Why is this 27 negative and the 9 positive? Or is that right?
You said it right, but you wrote it wrong.
Why? I've got a subtraction sign, so that's where that comes from. Why is this 27 negative? Negative 3 cubed, so it's negative 27. Same thing, I've got this minus sign that comes down here, but square it, it becomes positive now. So we've got 12 minus 8 thirds minus 2 plus 18 plus 9 minus 9 halves. Yes, it'll be minus 9 and it'll be plus 9 halves, won't it? Because I've got 1, 2, 3 negative signs. Plus 9 halves. You see why it's you have to be very careful with all this. So I've got 30 minus 11 minus 8 thirds plus 9 halves. 19 minus 8 thirds plus 9 halves. Whatever, that's, 19 minus 16 sixths plus 27 sixths. Is that right? 19 plus 11 sixths, and whatever that comes out to be. 20 and 5 sixths. Okay? Are y'all okay with that? I get the feeling they're just talking about me sometime over here, about how stupid I am. You just because y'all don't understand what they're saying, so it just seems logical. They're saying, "Gosh, he looks so funny today," or he has no idea what he's doing. Okay, I know. I'm just messing with you. Okay, I'm just messing with you. Okay, so, but there we go. Okay, so that's good.
Mr. Ely?
Yes.
You know me so well because right when you said, Colin, why don't we do that over there, I had already written
Yeah, I knew some people were headed there, okay, and I figured you were probably one of them. Okay, so let's see. So do you understand? Now, if we don't give you any limits of integration, you got to find some. All right? Find the area of the region between the graphs of this and this.
I don't know what that looks like. It's got a cube end.
Yeah. Now, this is where it gets a little scary. Because, as Sam said, we look at this and we say, I don't know what that looks like. That's where a graphing device is extremely beneficial. So I'm going to pull out my graphing device over here. I think. I thought it. There it is. And it's important that you know how to graph these on your calculator, because I do not expect you, I expect you to be able to look at this and say it's x cubed, so it's a funny looking s. It's going up to the right. But past that, I don't expect you to know what that looks like. So I'm going to go to my calculating device and graph f as the first function. That's going to be 3x raised to the third minus x squared minus 10x. And then at the same time, I'm going to graph the other one as the second function. Negative x squared plus 2x. And to start off with, let's just graph both of them at the same time. So let's try that. So if we graph both of them. That's ugly.
Why is the slope field there?
You knew that was a slope field. I'm impressed. That's good. All right, so let's see if I've got a program running somewhere. Program, calculus. Calculus made easy. Quit that program. Okay, so now let's go back and graph that again. That's a little bit better. Let's zoom standard. 6. So I do all my stuff on my graph, and it threw those graphs away, so I'll get to type them in again. 3x raised to the third minus x squared minus 10x. And the second one is minus x squared plus 2x. And graph. And look at what we have. All right? Yes.
There's like 3 possible places you could be looking for the area.
This is one curve, and this is a totally different. Now read the problem. Find the area of the region between the graphs.
So we have to find all 3 areas and add them together?
That's what it appears, yes. Let's figure out where are our areas at, first of all. It looks like both of these curves intersect somewhere down here, doesn't it? And it looks like they intersect somewhere along in here. Somewhere along in here. Do you see any other places? So then we have 2 regions that we're concerned with. Okay? This region right here and this region right here. Because that's the only place that we are between the graphs. Okay? So now, what do you think we need to do? What's the next thing you think we need to do here?
Set them equal to one another.
Find out where they intersect, right? Okay, we graphed it with our calculator. Therefore, we have our calculator. Therefore, you can do this the easy way or the hard way. My suggestion is to do this the easy way. I'm going to go press second. If I put my writing device down, I'm going to go press second. There we go. Press delete that puppy. Second, calculate. I want to find the intersection. Now, I want to find all 3 places. So remember, you need to be close to the place that you're trying to find. So I think I'm close to it there. First curve, second curve, yes. We got x equals -2, y equals -8. Which one of those numbers do we want? The x equals -2 or the y equals -8? X equals -2. So we know that that's one of our points of intersection. We come back to our calculator. Calc intersection 5. First curve, second curve, enter. We got x equals 0. Second, calc. X equals 2. Okay? So write down what the integrals are going to look like, please. You're going to have two different integrals to do. Write down what your two integrals look like.
Wait, which one's the top?
It's a good question. Which one's the top? This, all right, looking up here, the dark line is the second function, the negative x squared. The lighter line is the x cubed one, okay?
Well, it looks like in the first integral, the x cubed was the top function, but then in the second curve, it's the negative x squared.
Okay, does everybody agree with Samuel's deductions? The first one, he says in the first integral, the 3x cubed is the top. And in the second integral, the negative x squared is the top. So guess what? You've got two totally different looking integrals. -2 to 0.
Always wanted to do
Top minus bottom and then in our next integral we're going from 0 to 2 of top minus bottom. 3x cubed minus x squared minus 10x. Now, is the integration there hard? No. Okay, you should be able to do that. Just a lot of it, okay? A lot of places to make mistakes. Wouldn't it be nice if you could use your calculator to do that? We could, couldn't we? Let's talk about it and see if we can figure out how to do it on our calculator. All right, so we need to... First thing we need to do is we need to go here and make two more new functions. Okay? I've got the 3x cubed and I've got the negative x squared. Now for y3 I want to be this blue function right here. Top minus bottom. I can type all of that over, or I should be able to go right here and say variables, y variables, function y1. So whatever I've got in y1, it's going to put there. Okay, watch again. What do we want this to be? y1 minus y2. Minus. To put y2 in there, I hit the variables key. Go over to y variables, function, and go down and choose y2. So by doing that, it puts the two functions in there for me. All right? Now, if you don't want to do that, you can do it by hand, but this will get you there. Now we need to integrate, don't we? We want to second calculate the integral. What's it going to try to calculate the integral of, I wonder? Look up here. Look what's in the top of my screen. It says y1. Is that what we want to integrate? 3x cubed minus x squared minus 10x? No, we want to do that minus the other. So if I press my down arrow, it changes to y2. Is that what we want to integrate? No. We want to do y3, which is y1 minus y2. So we're calculating that integral. What's the lower limit? -2. What's the upper limit? 0. And watch what happens. There should be my answer, 12. Now, Can we do this rather quickly and see if we got the right answer there? Or see if we did something wrong with the calculator? That would be 3x cubed minus x squared plus x squared, right? Won't that be minus x squared plus x squared, so they'll go away? Minus 10x minus 2x minus 12x. So that's x to the fourth over 3/4 x to the fourth over 4 minus 6x squared. Evaluated at negative 2 and 0. Put 0 in, we're going to get zeros out. So I'll have 0 minus, put negative 2 in, we get 16 times 3 is 48, divided by 4 is 12. Put negative 2 in, I get what? 4 times 6 minus 24. 12 minus 24 is negative 12 with a minus in front of it is 12. How about that? The calculator gave us the right answer.
I didn't get the right answer on the calculator.
You didn't? What did you get?
5 and a third.
Okay, let's go back through the steps. Go to second, calculate. Number 7. Did you press your down arrow to be sure that... All right, first of all, is that what you've got for y1? 3x cubed minus x squared minus 10x. All right, go to y2. You've got negative x squared plus 2x.
How do you go to y2?
Just press the down arrow on your calculator.
Negative x squared plus 2x.
All right, go to y3. What does it say?
y1 minus y2.
Okay, so you want to leave it there. Change your lower limit to negative 2. Press enter. Make your upper limit 0. Press enter.
I just didn't go down.
Oh, you didn't go to... So you were just getting one piece of it there, okay? So now we've got 12. You can follow the same steps. What's going to be different to find this green integral down here for us?
You can do y2 minus y1.
All right, so here we're going to do calculate the integral. We're going to go down. Remember, we put that one in as y4, didn't we? Well, why isn't it there?
We haven't plugged it in yet.
Oh, we haven't plugged it in? Nope, we haven't plugged it in yet. You're right. So what's y4 need to be? The reverse of that. How do we get to y2?
Variables.
Y variables function.
Number 2 minus variables, y variables, function number 1. Okay, now we can calculate the area. And we go all the way down to y4. The lower limit is 0. The upper limit is 2. And we get 12 again. So what's our final answer? 24, because we were looking for the two things together. Now, truthfully, you probably could have done the integration just as quickly by hand. Some of you, I'm sure you could have done it faster by hand. But what if it's a very complex equation? What if, or not necessarily complex, what if it were just 7 or 8 terms that you wound up having to do? You know, a lot of places to make mistakes. So either way, you need to be capable of doing either one there. Okay, so if we don't give you limits of integration, you find them. If the curves cross more than 2 times, you've got more than one integration to have to do. All right, last problem I think we're going to look at here. Now, I want you to forget about those little squares in there, okay? Don't look at these rectangles right here. Okay? Don't look at those. What I want you to look at is the 2 functions that we have there. This function and this function. All right? And we want to find the area of the regions bound by those 2 things. Okay? What would be our limits of integration with what we've been doing?
Negative 2 and 2.
All right.
2 and 8. Negative 1.
All right, so we would be going from negative 1 to 2. That's this number to this number. What's top minus bottom? Ooh. All right, let's look here.
No, that's not right.
That's not right, is it? Because we're going to be going from here to here. Does that get all of our region? No. So where do we actually need to go all the way to?
3.
We need to go all the way to 3 out here. Or whatever this point is right out here, which, yeah, that's going to be 3. So we need to go all the way out to this place. So we would need to integrate from -1 to 3. Right? What's top minus bottom? The line's not top over here. Is it? The line is the top function until we get to right here, isn't it? But once we get over here, remember, we're talking about this region right here is what we want to find the area of. So we've got, this is the top function to here, and then suddenly this becomes the top function, doesn't it? Ooh. So this is one where we've got to do 2 integrations as well, right? Furthermore, these are x numbers, right? So we've got to solve this equation up here for y, because we got to have x's to put in down here, right? Agreed? Okay. Now, I want you to do something. Everybody, do what Colin's doing. Turn your head sideways. It's got to turn it this way. Madeline, that means you're going to tilt your head to the right, okay? I know you can't see what we're doing here. Tilt your head to the right. If you tilt it to the left, you've messed up, okay? Tilt your head to the right and look at it. What's the top function all the time now? The parabola is always the top function suddenly, isn't it? And the line's always the bottom function. Would that be easier to integrate? Because then we've just got one function to one integration to have to do. All right, so if we could turn this thing on its side, it'd be an easier problem to integrate. Well, what do y'all think? Is it okay to turn it on its side?
Yeah.
Why? Area is the same. Okay, so we're going to turn this on its side. Instead of, and this is where it starts getting a little bit abstract and students start getting lost, okay? Instead of integrating from here to here, okay? We're not going to integrate from the green dotted line to the green dotted line. We're going to integrate from here to here. We're going to be integrating that way.
So we're going to have, instead of x's right there, we're going to have y.
Exactly. That changes everything to y's, okay? So we're integrating now from -2 to 1. We're integrating from this. Say what?
So I was right.
So you were right, yeah.
I just didn't even know it.
So we're integrating with respect to y now. We're integrating from the lowest one, -2, to the top one, 1. Okay? Now, so if we're still using our top minus bottom, what's our top function? The parabola-looking thing, the 3 minus y squared. What's the bottom one? Well, the y plus 1. Be sure and put that y plus 1 in parentheses. And now that suddenly becomes an easy problem to integrate. Okay? It's wander time. All right, let's finish this problem and then you'll have an hour to work on problems here. Integration should be straightforward here. It's 3y minus y cubed over 3. This would be minus y minus 1, so I'm going to make it minus y squared over 2 minus y. I recommend to you that you write out every step here, because if you don't, you're going to miss something and you're not going to know why you missed it. Okay? So those of you that like to do the arithmetic in your head, at least for a while, I wouldn't do that. Remember, it's the top number, so it's 3 minus 1/3 minus 1/2 minus 1. minus the bottom number, that's going to be a negative 6, a positive 8/3, a negative 2, and a positive 2. Is that right? Negative 2 and then a positive 2. And then keep cleaning from there. Get 2 minus 1/3 minus 1/2 plus 6 minus 8/3. The minus 2 and plus 2 go away. 2 plus 6, I get 8 minus 9/3 minus 1/2. That's 3. 8 minus 3 minus 1/2. 5 minus 1/2. 9/2. Could I take this problem as it's written right here and integrate it on my calculator?
Just change it to X.
That's right. The y's and the x's are not going to make a difference. So if you were to put this into your calculator, 3 minus y squared minus parentheses y plus 1, integrate from negative 2 to 1, you should get the same answer. I'm not saying you need to be able to do that with some problems because there's some you can't do any other way, but this is also acceptable to do there. So that's all of the lecture on area. You now have a homework that you can be working on. It is due on Tuesday. You have a web assign you can be working on. I believe it's due on Friday of next week. Not today. You've got 2 sets of FRQs between now and spring break. Week 14 and week 15, okay? And a mock exam on the 27th. There will be no test before spring break. We will not take another test before spring break.
We're going to try to fit 3 in after spring break before our exam.
Don't worry, okay? Don't worry. But there will not be a test before spring break. You've got to remember, area and volume is all we have left, and we just finished area. So we only have volume left to do.